This episode is brought to you by Lamp Rainierson. Lamp Rainierson provides landscape architecture, planning, and civil engineering services. From community-wide master plans to land development, Lamp Rainierson incorporates sustainable design principles and equity in all of their projects. You're listening to the Booked on Planning podcast, a project of the Nebraska chapter of the American Planning Association. In each episode, we dive into how cities function by talking with authors on housing, transportation, and everything in between. Join us as we get booked on planning. Welcome back, bookworms, to another episode of Booked on Planning. In this episode, we talk with authors Robert Sroufe, Craig Stevenson, and Beth Eckenrode on their book, The Power of Existing Buildings: Save Money, Improve Health, and Reduce Environmental Impacts. This is a book that's been on my personal reading list for a few years now, so I was excited to finally get to reading it and talk with the authors.
Yeah, reading this couldn't have come at a better time for me, as I'm actually considering improvements to my home, namely adding rooftop solar after we lost power from a storm a few months ago. And I learned why I might want to focus my initial energies towards the envelope of my house instead.
Yeah, it's something that I considered for my home as well. And after reading this, have considered upgrades to my home's envelope as the first step, followed by improving HVAC equipment and then renewables as the last approach, which is described further in the book. I was a little surprised that there's an online group out there for residents in New York who never have to use a heating system because their homes are so well designed.
Yeah, that really was cool to learn about. And I'm such a cold-blooded person that if I could maybe get my envelope up to stuff, maybe I wouldn't ever have to use my heater again. So that would be cool. I really enjoyed this conversation and learned a lot, like rethinking how I think about the city of Pittsburgh. So let's get into our conversation with Robert, Craig, and Beth on their book, The Power of Existing Buildings.
Robert, Craig, and Beth, thank you all for joining us on Booked on Planning to talk about your book, The Power of Existing Buildings. This book is based on the idea of the natural order of sustainability: passive first, active second, and renewables last. Can you discuss what this means in terms of building design and where this concept originated?
Sure. So we started the Oros group to answer one question for building owners: did you get what you paid for? And when we did that, we had to go really deep in the world of building science, because it's in the world of building science where you discover how to build a high performance building without having to pay a significant premium to do so. And it's in the laws of building science that we came across a standard called passive house, which is a little bit of a misnomer in that it's not just specifically about houses, it's for buildings. And buildings all over the world have been built or renovated to a passive house standard. The natural order of sustainability is kind of our layperson language to describe that standard. And the idea is that there is a natural order to how you begin and end in the world of building science to build a high-performing building, meaning that you start with the passive systems of a building first, which is really everything that separates the outside air from the indoor air. That is what defines an envelope. And so that's passive, in that once you build it, nothing really happens to it, and it's rather enduring. It lasts for a very, very long time. And then the active piece is really the second element of it, which is once you get a high-performing envelope set, now you can start to think about how to build those active systems, meaning mechanical systems, heating, ventilating, air conditioning. You can think about doing things differently. They become much less complicated, much simpler, and ergo much cheaper, because you've built a high-performing envelope. So then you take the high-performing envelope, you add it to simpler, easier, cheaper mechanical systems, and those two together allow you to really think differently about renewables. So instead of building a big photovoltaic array to offset a building that's not performing as well, now you've got a high-performance building, and the amount of renewables you need gets much less. Again, it gets much simpler and much cheaper. When you put all of those three pieces together, now you've built what we consider to be the highest performing building for the lowest possible cost, because you've just done it in a smarter way.
Let's talk about your version of the first cost argument. So I work in redevelopment all the time. And one of the very first things that we hear is that it's cheaper, easier, better, take your pick, whichever, to just level the existing building that's there and then start from scratch. One of the main premises of your book is that's not always or even most often the case. So how should people start thinking about that first cost argument?
Oh, great question. Thanks again, Stephanie and Jennifer, for having us. When thinking about first cost, we try to think about this more as a systems opportunity. When we look at first cost and only lowest cost is typically where most businesses go with many decisions. And those first costs, if I put this in the context of like a transportation system, I can, drive 60 years out of my life, about 14,000 miles a year, and spend maybe upwards of $130,000 on gasoline for internal combustion engine. And it seems like it's a low cost approach to doing it to begin with. And I think about only the first cost of that. But if I actually look at that whole lifetime of driving and I did it with a better system and did it with, let's say, an e-vehicle, it'd be 90% more efficient. I'd spend maybe $13,000 in 60 years. And I would have overlooked the lifetime cost of this, the life cycle implications of this, the operational costs. So when we talk in context of business and first cost, for me, what really tends to land well is that if you're only looking at the lowest cost bid coming in to begin with, you've missed the entire opportunity to think life cycle, think whole systems, and think about how that building is connected to everything else that we don't typically measure, which can also include environmental impacts avoided and human health and productivity that go well beyond just a first cost.
So I'll add that even just in the last couple of years, the idea of embodied carbon has generated so much interest and enthusiasm that the idea of leveling in a perfectly good existing building that might just need to be updated has kind of gone out of favor. I mean, think about schools, for example. So what's often been the case is that project teams come in and offer a school superintendent a choice, right? For the same price, for the same cost, you can either bring a building down or build a new one, and your price is about the same. And the superintendent says, well, oh my gosh, I want to build my own building. I want to build it the way I want it. For 50 years, that's been the way people have thought about that choice. Today, I would say it's somewhat flipped on its head. The embodied carbon that is already in an existing building is such that if you don't have to, you would never want to tear that building down. You would want to do anything you can in order to improve that building and bring it up to proper standards today and build the highest performing building for the lowest possible cost, which today would really lean towards leaving the building and not tearing it down.
Which, as a preservationist, that was a lot of where the field has gone in the last couple of years. Before it was save it for the sake of its history, but now it's, in addition to the history, there's all of this embodied carbon in that building, and it makes way more sense to maintain these buildings and renovate them.
I think that's a great example, Stephanie. I mean, the historic preservationists have gotten much smarter too in building science. And now they're understanding that there are things you can do with a building that if historic preservationists give design teams a little bit more wiggle room on like how to build up the envelope properly from the inside out, but do it in a way that allows us to get better performance, we can have our cake and eat it too. We can do both. We can have a historically preserved building and a high performance building. And I would say historic preservationists and the preservation group in New York City is a great example of where they're finding that balance between, historic preservation and being really tight about it to loosening up a little bit when you've got building science people who can help you build a better mousetrap.
One of my favorite quotes in the book is that the building code represents the worst possible building that you're legally allowed to build. And sometimes it feels a little bit like some of the sustainability rating systems, LEED, for example, have a tendency to result in this as well, depending on how you use it. If you're just adding a bunch of bike racks to get a bunch of points, but it's really impossible to actually bike to your building. How do we avoid falling into this trap of seeking sustainability designation that's only useful on paper?
First of all, Stephanie and Jennifer, we are excited to be here, and I'm happy to be talking to you guys today. It is one of my favorite quotes. It's those quotes you just hear and you can't unhear it, right? Because it's just true. And the problem with the building codes is that it's not that the codes are terrible. For example, it's the adoption of the codes are left to the local municipalities. And, in our jurisdiction here in Western Pennsylvania, we're 2 codes behind because there's certain lobbies out there that prevent us from adopting the latest codes. And that's the problem, right? So then owners are faced with a decision. I want to build a new building or I want to do a retrofit. What do I do? Well, more times than not, they chase code because they want to spend as little money as possible. And to Robert's point, they don't look at the overall impact of all the costs, right? They're chasing one parameter, and that one parameter is the cheapest building I can build. But when you go buy a car, do we do the same thing? No, we don't, right? We want those amenities. We want those customizations that make us feel a little more comfortable, that protect us a little bit more, that have a little bit more of a safety valve for us. So the idea there is that we think that building owners are asking the wrong question. And the question they should be asking is, how good of a building can I build? Once I know that, then I want to weigh in those three factors, and those three factors are first cost, building performance, which is an operational cost or OpEx, and then the goals that we want to reach for all parameters of performance, from air quality to light and sound to material toxicity and everything else in the building. So if the building owners only understand one edge of that spectrum and they never see the other edge, performance, right? One edge is the worst building I'm legally allowed to build, and the other edge is I don't know what that is, right? They don't know what it is. They're asking the wrong question. So when we say if you ask the right question, then all of a sudden you can see the value. If I understand the right edge of the spectrum on performance, then I can look at value from an OpEx perspective over the next life cycle of the building. That gives us the opportunity to make better decisions. And I believe that, I grew up in this industry and spent a lot of time in construction. LEED, foundationally, is a wonderful system. We support it. We still believe in it. It got us on the pathway that we want to be on. But the problem with LEED and ASHRAE and other programs out there is they say you must be better than by code by X, whatever that percentage is. And we all know those programs, right? So now all of a sudden we're asking the wrong question. We're starting with the worst building we're legally allowed to build, and we want to incrementally get better. And incrementalism doesn't work. It just simply doesn't work, right? Think about it. When we incrementally want to improve our buildings, what do? Replace all of our light fixtures. Uh-oh, that didn't get us there. And then we replace all of our variable frequency drives. Uh-oh, that didn't get us there. And the new buzzword of the day is heat pumps. All we have to do is do our heat pumps and we're going to get to our goals. Uh-oh, that's not working. And that's the problem, because they're violating, to Beth's point, the natural order of sustainability. They haven't aggressively reduced their loads to get them into an efficient building where everything else starts to work. And when you violate the natural order of sustainability, you're going to pay a premium because you've got to supplement for what you missed. If I don't lower my loads and I'm going to deal with this all with active systems, how am I going to do that? Well, I got to build, more elaborate, bigger active systems to heat and cool my building, because all that energy is going straight through my envelope. That's where this all comes together. All the questions you guys are asking us and what we wrote in the book, it all comes together and it just makes sense. Reduce your loads, right size your system, do the math across the operational life cycle of the building, understand the right edge of that spectrum, and that's building performance. How good can a building be? So our recommendation would be to any building owner, if you're engaging in a new construction project or a retrofit of an existing building, the very first question you should ask is how good could that building be pre-renewables? Once you know that answer, you're going to make much better decisions.
I have to admit, I underlined that. We are always working with developers. They come seek tax and increment financing. They have to work with the city. I'm going to throw that into my meetings. Be like, I don't know, maybe we shouldn't build the worst building we're legally allowed to. Let's elevate that through.
That's great.
I equally thought that another point that you guys made that just hit me, and was everybody should probably know this, but I've never thought about it, was that if you want to know if a current indoor environmental quality is good or not, you should just ask the occupants who are in the building. Stephanie and I complain about our office all the time. It's always so dang cold. But you point out that an uncomfortable occupant is actually a symptom, not the root cause. So how would you tell building owners to differentiate between symptoms and causes?
I love that, Jennifer. And sometimes you don't even have to ask them, right? You can see by what they're wearing, whether the windows are open, the fans are on, the air conditioners are running, and they're all next to each other in the same space, doing these different things. So as we spend, 93% of our time inside, it's amazing how much occupants don't get to interact with those systems that they depend upon. And that's part of the symptom versus causes piece, is that when they're uncomfortable, it's a symptom of an underlying problem. Their interaction with the system, lack of interaction, bad systems maybe to begin with, no data, no indoor air quality measures, all that kind of pile up. But if we ask the question 5 times, and the question is why are they uncomfortable? Why did they turn on that unit? Why did they open the window? Why? And as we answer that each time, after doing about 5 times through, you actually get to an underlying root cause of something. Otherwise, you're hitting on all the symptoms that are associated with it. So as we work our way down through symptoms into a root cause, and think about spending 93% of our time inside, we can then start flipping that into, when we better understand this and people can better engage in those systems, students will do better on exams in school. People will recover faster in hospitals. We will do better in terms of our own human health and productivity. And what we found in retrofitting buildings in the past too is that it's a good ROI to begin with, right? When we start touching these things. And then as we look at environmental impacts avoided, It gets even better. We can bring a 5-year ROI for something down to maybe 3.5 years if we look at that carbon and environmental impacts avoided. But if we add the human health and productivity piece, it can be 10 times better than the financials to begin with. And maybe we're taking something down from 5 years to 4 months in terms of its payback period, because we've finally taken all these things into account that are part of the root cause of something and a lack of human interaction within the system that finally sets us up for understanding that this ROI is an integrated bottom line and not just a single bottom line or something that's rudimentary. It's really dynamic, but we just typically can't get to it because we're treating symptom after symptom and not getting to the underlying problem.
Yeah, I totally agree. And I want to add one comment to Robert's response, as much as I agree with everything he just said, is that if you think about it from a building science perspective, how are we reducing our loads? We're changing the insulation value to a climate-specific insulation value. So code may require an R18, yet the climate-specific insulation value we should target for load reduction might be closer to an R25 to an R30. So you're talking a few more inches of insulation. And then you want to put in an air barrier that is connected all the way through 6 sides of that envelope, all 6 sides of the cube. We do insulation and we do air barrier today, but we don't really test it, right? If you drive by and look at a building and they have Tyvek on the side of the building and it's flapping in the air, and it's not connected to the windows and doors or the sub-slab insulation, then it's really, I mean, the air doesn't care where the hole's at. It's going to go out of the building wherever the hole's at. So when you take an approach to high performance building, we're connecting our thermal and air barriers. Now think about that. If I connect my thermal and air barriers, I've got a pretty tight building. That means I can bring the air into the building in the way I want it to come in, not infiltration and exfiltration, but through my ductwork, and I can throw a MERV 13 on it. Guess what I just solved? Indoor air quality. They're connected. So when you build a high performance building, Beth and I always say, and to our clients in our business, is that this is the foundation. If you build a good building, you can get after every performance parameter. And we define those, and we talk about it in the book, in our owner's project requirements. And OPR, over owner's project requirements, is a set of goals and targets. It's metric based across every parameter of performance in the building. And when we set that, we find that when we build our envelope the right way, we're solving about 80% of those OPR metrics. And that's where Robert's getting at on the IAQ. He's talking about the value of IAQ, and we're telling you how easy it is to deliver it in buildings. Just stop building porous buildings, buildings that are air leaky. And now all of a sudden you can get at IAQ pretty quickly and easily.
And speaking of performance, in the book, you discuss that the building industry is moving from performance-based standards to performance-based accountability. What's the difference and why is this shift in the right direction?
So a couple of things, let's talk about what it is. It should have every building owner kind of on their toes right now, because if you are going to build a new building or you're deep renovating an existing building, you need to be aware of performance accountability, which looks and feels like fines. It looks and feels like accountability based on performance. So depending on how well your building's performing, and now, the disclosures are typically in place in most cities. And now many cities, it will look and feel like Local on 97 in New York, or Berto in Boston, or Energize Denver, where, you have to get to a certain level of performance or you're going to get fined. So that's performance accountability. Now, is it the right thing? I don't know. I mean, it's the only thing. If we're not making progress on our environmental objectives and goals, and there's no feedback loops any other way to tell people if the buildings are moving in the right direction, as Craig said, and as Robert said, buildings account for so much of carbon emissions, that if you don't have any other feedback loops, that's what you're left with. So I don't know if it's the right thing. Right now, it's the only thing. Now, let's fast forward a little bit. 3 to 5 years from now, we tease out a lot of this in our book. It might require a second installment of The Power of Existing Buildings to really get after this idea of the data science side and what's possible from a data science side. Can you use data to inform a building and have the feedback loops that give you an idea of, here's where your building is performing today from a trended standpoint, here's what's possible. Here's what building science says you can get to or you can perform at. And now we're going to give you the feedback loops that tell you how to get there. So if we can shift the paradigm from stick to carrot, now all of a sudden we've got a different way of thinking about performance accountability. So it's there. Everybody should be aware of it and slightly nervous about it. But is it right? I think we can do better. And I think we might need another book in order to explain how to do better.
Well, if you write it, Stephanie and I look forward to reading it and discussing it on a future episode.
Outstanding.
And we've touched a little bit on this, but integrative design is just absolutely vital to successful sustainability projects. Stephanie and I are in the Midwest, so maybe we're just not seeing the industry shift that might be occurring on the coasts. But how do we move the entire design industry as a whole toward an integrated design approach? Because we're not seeing it out here as much.
I tend to, with my own students, in a graduate school setting, start the conversations with design thinking and realizing that we're pulling from existing approaches that are across industries. We've been doing this for a long time, but we don't seem to leverage them very well in certain specific places or maybe at different times. From a design thinking standpoint, we know that the earlier we can do this, the less it'll cost us, the more dynamic the impact, the better the end result will be. We've seen this in terms of how LEED was set up to begin with, and it was launched as an integrative approach. We see this in integration in information systems, information technology. It's part of integrated management now in terms of how I teach about how sustainability is already part of every business function. We already have known drivers, enablers, and performance metrics for this. So the earlier we move design into the conversation up front, the better we get at design thinking, life cycle assessment, and better high performance buildings that are existing buildings. Because as we redesign, not just the first time, because we may not have been part of it, right? But the next iteration and the next time around, it's the design that is, even been said by others, design is the first signal of human intention, right? If I go to a building down, if our intention is to have high performance, sustainable buildings, then we need to have an integrated approach. And the things that we've done for the last 40 years, throwing it over one functional wall to another, and then to another, haven't resulted in anything close to what we need for the future that needs this high performance, decarbonization, embedded carbon, and an opportunity to actually understand the real value of these buildings when design wasn't part of the early thinking.
Well, Craig mentioned earlier about the owner's project requirements. It is probably the most impactful tool we've come up with. It's, like 11 by 17 sheet of paper with all numbers on it. And those numbers are specific metrics to guide individual pieces of performance. And we have found that drives integration, because you've got people all agreeing on those goals. And now instead of writing paragraphs of narrative into what their intentions are, as Robert was talking about, the intentions, now we have people saying, oh yeah, I can do that. I can deliver a system that delivers that type of performance. And so we stop this whole back and forth narrative of it's their responsibility, no, it's her responsibility. Now it's really a collaborative environment and everybody's agreeing on the outcomes as opposed to the path to get there.
It feels like the design profession, like architects, engineers, that side have a big role to play in this shift because they're the ones that can advocate for and provide the guidance and kind of steer building owners in the right direction and kind of lead them along the way.
Yeah, and we can kind of tease out a little bit of a breakthrough, I think, in how leaders in this space are starting to think instead of that incrementality of here's where we are and how much better can we get. Any project team worth their salt today, whether it's a building owner or an architect or engineering group, should be asking of themselves the question, especially of an existing building, how good can my building get? It totally reframes the way you think about a high performance building. Instead of trying to find diminishing marginal returns from where you start, you go to what's possible, and then you start to trade up based on diminishing marginal returns. And so it's really the best way to get all of the juice out of the squeeze is the way we say it, right? Like if you're going to tackle your building, tackle it and get everything out of it you can. Get as much energy out, get as much indoor air quality in, get as much thermal comfort in, do as much as you can with the time and the money that you have. Because once you do it, you're not touching that building for another 30 years. You're not going to touch those systems again until until they trigger out.
Yeah, and a lot of the examples in the book are primarily for larger buildings, but a lot of our cities have upwards of 70% single family dwellings. And if a large portion of them were rehabbed under natural order method, could have a significant sustainability impact. At such a smaller scale, is it still possible to see the same ROI and energy cost savings like smaller HVAC systems resulting from a better envelope in the building?
Oh, 100%. Absolutely, it does. But the question's a really, really interesting question. I want to break it down into two parts because I think if I can do that, I can answer it for you two different ways. Number one, let's start with triggers, right? The title of the book is The Power of Existing Buildings, and that's purposeful. And the reason why we named it that way is because we hear these developers calling these buildings stranded assets. And we hear them, referring to these buildings as buildings that are inefficient, and they just look at them as a negative. We look at that as positive. Why? First, let's define what a trigger is. So a trigger is, it's life cycle, stuff breaks. it's deferred maintenance, planned renovations, any opportunity to touch the building, to renovate the building, to do something to mitigate the building. If we maximize our triggers, stranded asset has every trigger you can imagine. We've seen stranded assets that need the roof replaced and windows need replaced and the building's vacant and needs renovated and the systems are all at life cycle need replaced. Well, guess what? We just touched every system that we want to touch to transform our buildings from, poor performing buildings to high performance buildings. So the concept of triggers is really, really important. And that will be persistent across any typology, single family through large commercial buildings. If we respect triggers, what we want to do is we want to stop replacing a kind. And that's what we do. Stuff breaks, we replace it. And we just immunized our building for the next 20 years because to Beth's point, we're never going to spend money on a system that's not at life cycle and replace it. So that's my first point. And the second point around larger buildings, the benefit of larger buildings is they're easier. Now that might sound counterintuitive and you might think, well, wait a second, big buildings must be more difficult because they're larger and more complex. Think about it from a building science perspective. When you think about the surface of the wall versus the indoor volume of air, that ratio changes. It makes the envelope less important. It makes the envelope less critical. So my envelope doesn't have to be in R30 like it would have to be in a smaller building. It has to be closer to a code, R18 to R20, and we can hit all the performance targets we want to hit. We still need our air barrier and we still need systems to be right sized. But for the most part, big buildings are easier than smaller buildings. And that's one of the reasons why we go there. Plus, big buildings are super, super inefficient. I mean, just walk outside during COVID and look at the buildings with all the lights on and all the equipment still heating and cooling with nobody in these buildings, right? They're not being set back. So for us, there's a lot of waste in these big buildings and they're easier to do. For us, I think if we attack that, we can attack the biggest kind of problem we have. But the solutions work, whether or not it's single family or large buildings. So those were the 2 points. The 2 points is the size differential, big buildings are easier. And the second point is triggers. We got to look for our triggers. So if you have a single family home and your focus is on that, a lot of people say, well, single family home's harder to do. Well, how many homeowners are going to retrofit their inside walls, rip out their walls, put better insulation in, or do an outside-in retrofit where you put your insulation and new cladding on the outside? They're looking for the easy button, photovoltaic array, better windows, maybe a heat pump system. And those are all good, and we should do all those because they're going to matter. But to the extent you can touch the envelope and reduce loads, now guess what? Now I don't have to turn those systems on for probably 8 months of the year. And that's really what happens in Passive House. There's a club there you guys should research. It's called the No Heat Club. And these guys are in upstate New York. They never turn their heat on. Never. They're paying for their single family homes an average of $150 to $200 a year in utility in upstate New York in the middle, including the middle of the winter because they have a no heat club. They don't need heat. So again, these are the things that we should be thinking about and we should create financial incentivization programs around, but we have to understand that the easier levers to pull are in those big buildings with a lot of triggers, those so-called stranded assets that are in fact assets, which is the theme of our book.
Well, and we haven't talked much about the Inflation Reduction Act, but the Inflation Reduction Act put a lot of money out there set aside for small single family homes. And depending on where your single family home is, there might even be more money available. So what happened early in the Inflation Reduction Act is the money was set aside for states to basically build programs and get that money from the federal government to bring into the individual states. Most of the states have completed their programs. They now have all of their structure around how they're going to deliver that money. And it's for all the things that Craig talked about. It's not just replacing systems. It's for insulation, weather stripping, sealing, new roofs, new windows. All of those things are now available for funding through the state IRA monies.
Including PV, photovoltaic arrays.
Yeah.
Yep.
Yeah, we've seen a bigger focus on the renewable energies here in Lincoln, and we have a heat pump program that we just relaunched as of this morning. It just seems to be easier to fund those kind of simpler projects, I guess, versus, like you mentioned, it's much more challenging on a smaller single family home to do the envelope. But it would be interesting to see what other communities, because there's weatherization programs that have been around in a lot of communities, but they don't seem to be as holistic of an approach as you really need to see the indoor air benefits.
Yeah, and that's where, to your point, the scale of a larger building to do the physics-based modeling and simulation that we do that really is precise about where you need maybe a little bit more insulation or you need a little bit better sealing. We can get very precise in a sophisticated physics-based model. those don't necessarily exist for the single family home in the same way. There's other testing and other modeling you can do, but it's not quite as sophisticated. And so it's a little bit more difficult to find the money to pay for those. Although California has a program now where they are putting $5,000 aside for building owners and smaller single family homeowners to be able to do some of that modeling and simulation work, albeit on a smaller scale. They're able to do that, and the state has put that money aside. So as we get a little smarter and a little smarter every year, more of the dollars flow to the right things, as opposed to just throwing money at something, having somebody check a box and thinking somehow they did something magnanimous. There's this accountability piece out there now that people are saying we need to know that it made a difference.
Well, I have to admit, reading this book came at probably the most perfect time for me because I was starting to think about adding solar to my home. I have a 1950s war home and I work with developers. We've talked about how to like renovate and whatever. And so I was like, well, maybe I should just plop some solar panels right on the roof. Seems simple, help bring everything down. That's always where my developers go to. The first conversation is always about, can we bring in the solar? Can we put a wind generator on the roof? But as you guys talked about at the top, your system brings in renewables last. So can you help me put a response in my back pocket when I talk with these developers and tell me why renewables should be brought in as that last step?
Yeah, I would love that, Jennifer. I went through the same process with my own home, right? In this general context, in that I have a home that's 50% larger than the average home in Pennsylvania. But I worked on insulation and envelope and bringing it down. So now it consumes less than 50% of the average amount of electricity for a home. So for a home half its size, it actually consumes less than half that. And then to go beyond that, right size mechanicals afterwards, and then look at my actual load, because then the size of the PV array that I put on top, like Craig alluded to earlier on, was that my PV array doesn't have to be, let's say, 100 units. It can be 70% smaller or 50% smaller, right? So I'm spending half as much on a system if it's half the size, and then still meet my needs. I then overgenerate with that, so I'm net positive with the house. I offload to cars. I can go 10,000 miles a year for less than $200 with a vehicle, connect systems to buildings, so I have mobility and not just a place and a space. So it generates something for me. In doing that, heat pumps are part of it, induction cooking is part of it, getting rid of fossil fuels, other things are all part of that space that I wanted to be part of. But renewables were our last decision because we wanted to bring everything else down as much as possible first. And almost like, that group that Craig talked about in New York, we wanted to try to get to something like zero. What if we could get to zero? In a passive house, if you heat 1,000 square feet of a home with a hairdryer, basically, why would I need a full mechanical system to do this? Make it as small as possible. And then I can invest in other things. The PVs are great. They're a great visual. By having them on our roof and other roofs, it increases the chance of others around you getting it. We put in 6 more systems around us, I think, within the first 4 years after putting our own in, and there's more coming. So I don't want to ever say people should not do it, but I think, as Beth was saying, a smarter approach is to go through this passive first, active second, renewables last, and then right size your systems and right size your payment for what you're going to be putting down for this. So that way you get a better ROI for that and it comes quicker.
So from the city side, what are ways that local governments can encourage owners of existing buildings to update their buildings with the mindset that spending more upfront on elements like the building envelope will pay off in the long run with reducing energy costs, for example, or just to avoid the fix the one problem versus looking at it more holistically, like we've talked about in the episode?
Yeah, it's a really great question because I think it's in some ways various states, governments, even the federal government that just recently the White House put out a definition at the end of last year on what zero carbon emissions really meant. What is zero carbon? And it defines the same way we would define it using the natural order of sustainability, meaning if you don't go after efficiency first, you aren't ever going to achieve, in their idea of zero carbon, you're not going to achieve zero carbon emissions. Like you have to wring all the efficiency out first, which is the right thing. I feel like as fast as we're evolving on the data science side, the best thing funders of any sort, state governments, local governments, federal government, foundations, anybody who's funding some of these projects should require automated feedback loops. I think what's going to happen next is instead of putting more and more sticks in place to penalize people, it's going to look more like carrots, meaning the higher performing projects and the teams associated with those higher performing projects are going to get the funds flow. So I think what's going to happen is the more that you're able to prove performance, the more you're going to get refunded. Not refunded, but funded again. So you'll get funded again. Like think about LIHTC, for example, and affordable housing. In my opinion, I think what's going to happen next is these organizations that are putting tremendous amount of dollars against affordable multifamily are going to start to require feedback loops and demonstration of results. And the more they do that, the more it will be the fastest propelling and accelerating of this work that I think we could get. And it's just going to be turning the lights on and making it more visible in terms of which projects are delivering and which ones are not.
One of the areas that the book focuses on pretty heavily is the city of Pittsburgh. And it's been a few years since you guys published the book. So can you give us an update on what the city of Pittsburgh's been up to?
Yeah, I think the city of Pittsburgh is one of those thought leaders in the nation that has a great story to tell. We were just with them down in Washington, D.C., speaking in front of a lot of other federal agencies and universities and hospitals for an event. And they committed to basically going to zero. And the way in which they did that is they put in their RFPs when they go out to architects and engineers that they must design these buildings new and retrofit to be near zero energy ready. And they're using the passive optimization methodology to do it. What's interesting is they don't want to certify. Now they're using all of the standard and they're using the commissioning requirements, which we believe are essential when you build a high performance building to commission it. And they've already started to put in feedback loops through this. They're called controllers that go into a building to do data aggregation. And they've started to put these in the buildings. So we've been involved, I think, in about 12 projects with the city of Pittsburgh over the last 2.5 years. And every one of those projects is basically, they can zero out with a small photovoltaic array at this point. And they're really incredible projects. So I credit, the city of Pittsburgh, when they got on this journey, reached out to the Rocky Mountain Institute. Rocky Mountain Institute came in and gave them a lot of guidance on how to set up their RFPs, how to train the employees within the city to understand these concepts and how to do it. And then they also reached out to Carnegie Mellon University, a local university here in the city of Pittsburgh, to help them further to go into operational mode for these and how to set up your smart building infrastructure to get the feedback loops they want. And I can tell you through design on the projects we're on, every single one of these projects right now is designed at those levels of performance they need to be. And I would say about a half a dozen of these right now. Does that sound right, Beth? About a half a dozen of these are in various phases of construction right now. So we are very eager and anxious, just like you guys, to see when these things go operational, how do they start balancing the operational performance with the design performance. But they're doing everything that they can in terms of the design and setting up the technology-based feedback systems in the buildings to get to those answers. So it's really exciting.
And they're a great example of jurisdiction that went through a process, right? First, they required disclosure. Then they required, any city building that's touched has to go to zero. Now they're talking about performance accountability in the form of data. And so while they haven't necessarily said, okay, if your project performs, you'll get another project with the city. And if your project doesn't, you won't. They're not going that far, but they're just turning the lights on. Again, it's always the first step, is to turn the lights on and make people aware of what's going on. And then what you'll see is adjustment. People will begin to adjust as they realize that the bar is now a little higher. The minute you do that, everybody raises their game. And that's the way we make more accelerated progress.
This is just showing my bias because I've never been to Pittsburgh, but I have to admit, I was surprised to find Pittsburgh, Pennsylvania, being the leader in this industry.
That's a relatively true statement. I mean, if you think about it, 10 years ago when LEED came out, 15 years ago when LEED came out, the city of Pittsburgh in the first few years for LEED led the nation in square foot of LEED projects. And we had some conferences here, national conferences. And I think that's attributable to, CMU, University of Pittsburgh, these institutions committing to the sustainability. And Robert was at Duquesne University at the time, and Duquesne was a leader on that with the Sustainable MBA program. And now Chatham University, again, another national leader in this space. I think it's because of those universities first and foremost, and then the businesses listening to them and starting to embrace them and not saying, well, we can't, here's all the reasons why we can't. You build out a proof of concept. PNC Bank was a very early adopter into that. They funded a lot of the sustainable organizations in Pittsburgh, and then he built a tower that's sustainable. So we've got demonstration cases throughout the city, which I think, Jennifer, it gives proof of concepts to the people who say, I don't know about that, right? That's what Beth had said when the city of Pittsburgh demonstrates, hey guys, we can do it. And if we could do it as the city, you guys can do it. And the university started doing it. And then we had a lot of demonstration projects and large organizations buy in. And then the city did it. And now all of a sudden, people aren't saying, I can't. They're finding other excuses to resist, but that's just construction, right? That's our market. But now we know we can.
Well, and because of the thought leadership of the city, which at the time Mayor Peduto really put a lot of, sticks in place and had accountabilities and requirements, and Mayor Gainey, who's come in behind him, is requiring the same things. He has not pulled back at all on those commitments to get to zero. So what that forced was the ecosystem of practitioners to evolve and to get smarter. And so now I would say Pittsburgh has an outsized ecosystem. We have an ecosystem bigger than anything we can do here. So if there are other communities around the country looking to do more of this work, all the practitioners are in Pittsburgh. That is a fact. So irrespective of where you are in the chain of construction, we have more practicing natural order sustainability people here than we're probably entitled to on our size.
Well, think about this too, Beth. I mean, when Passive House became popular and started to increase in its use in square foots in the United States, Pittsburgh is leading that for the first couple of years. I mean, New York codified it and they went way past everybody really quickly. But for Pittsburgh even to pace with a municipality like New York City in square foot of Passive House tells a story right there alone. So we've always been at that forefront in sustainability, to Beth's point.
That's fantastic. This booked on planning, obviously, we're book nerds. You guys wrote a book. Seems like you might be a little bit of book nerds too. Craig, starting with you, and we can kind of go down the line. What are some books you recommend our readers check out?
Well, for us, the macro trends in the industry are connecting buildings to technology for technology-based feedback systems. So I don't know if it's necessarily books as much as articles, because the industry is moving so quickly on the technology side of this, between data layers or data lakes that we support all the time series data for buildings, and then the digital twins or the dashboards, if you will, for these buildings. That technology is moving so quickly, Jennifer. For me, it's a matter of staying connected to those macro trends and reading those articles. And we've published a few in the Construction Real Estate Journal. They're on our website. You can look them up. I think Nexus Labs does a lot of podcasting and they do a lot of journaling in there. And we pay attention to that. And then the Passive House Accelerator. You can go on a Passive House Accelerator and really look up any subject you want to look up. So to me, I think it's a different way of reading things in terms of where we're at because of the pace. On the building science side, though, we think that our book is definitely one of those books that's in the front.
Well, I will say I just met an author yesterday and I was super excited because his book is interesting. He's a developer out of Charlotte. His name is Gary Chesson, and he's a developer out of Charlotte, and his book is Creating Trinity. So he comes at it as a real estate entrepreneur and investor. So he's got a really interesting set of stories around what Charlotte has done as they've continued to grow at really incredible rates, and also how they got through COVID. And so I heard him speak because I really loved his book. I heard him speak, and I would recommend Gary Chesson's book.
I can do the blatantly self-serving thing, right? And say my own book's on supply chain management and sustainability. But in reality, I'd kind of more pivot this towards, I think, a bigger opportunity is to think about the context in which I work. And it's how health and longevity of the world we live in is impacted by education, and how university campuses are living learning laboratories, or at least they should be if they are not. And those buildings can be connected so that they are part of our curriculum and what we do. So I'm coming to you today from a university campus that's 400 acres. It's net positive, carbon neutral goals for it. 100-year-old buildings on site with ultra-modern brand new buildings, less than 10 years old, bioswales, renewables, microgrids, all that part of it, because it's part of what we want to have our students touch and be part of in learning, and be part of a space and a place that isn't something you learn, in talk, lecture, or a book. So I think university campuses is where maybe the next book should come from or be about in some ways. And I love that I'm part of a space that actually tries to live this. And what we do, we were the second sustainability school in the United States at Chatham University. Try to live this through our buildings, through organic certified farm on campus, the only one in the United States, and try to do something different in terms of how students get an education and an experience, and not just a degree or a class.
Have you guys heard of the book that ESG Mindset that Island Press put out not too long ago. Have you heard of that one?
I don't think we have.
No.
Yeah, that's kind of a good one too. They did some promotions around that book, and I didn't read the entire book. I read excerpts of it, and I'd love to go back and read it myself. It looks practical. So where ESG has gone is from picking low-hanging fruit to now, oh crap, what do we do? And, you've got CEOs of major corporations making very, very lofty promises and then handing those promises and those goals off to sustainability groups, ESG groups, to try and figure out how to execute. And so there's this process of going after a lot of this low-hanging fruit and then getting to the point where you can't, buy bamboo farms in wild places anymore and think that that's going to count. You now have to be much more transparent about how you're calculating your contribution in terms of carbon emissions. And so I thought that book sounded, of all of them that I see kind of come across my screen, I really felt like that one, and as I peeled it back a little bit, that one had the most practical input. So I think that's where potentially one of your podcasts and also just another look for your listeners.
Is it the ESG Mindset by Matthew Sekel?
Sekel.
Yep. Okay.
Yep.
We'll add it to our list.
I was going to say, we're putting together next year's list already, so we can add that through.
There you go.
And I have to share with you guys, I added your book. I'm going to be teaching an urban design course at the University of Nebraska this year. And I added your guys' book to the list because I was like, start them young, I guess.
Absolutely. Absolutely love that.
That's great. Well, especially if it kind of helps you reframe your thinking as you were getting ready to do something. There's how valuable it is in a professional environment, but then there's just how valuable it is just in knowing the right way to think about something.
Yeah, like I said, it changed the way I thought I'd redo my house. I'll start focusing a little more on my envelope first. So,
all right, Jennifer, I'm going to have to reach out to you and get a quote from my website. I think I might have to find something for you to add to our website.
Yeah, and we have had other urban planners at different universities contact us about using the book, so it's great to see it in use. And any feedback you have about that too would be helpful.
Well, Beth, Craig, Robert, thank you so much for joining us on Booked on Planning to talk about your book, The Power of Existing Buildings, Save Money, Improve Health, and Reduce Environmental Impacts.
Thank you. You guys were great.
Thank you for having us. It's an important topic. Glad you're covering it.
We hope you enjoyed this conversation with Robert Sroufe, Craig Stevenson, and Beth Eckenrode on their book, The Power of Existing Buildings, Save Money, Improve Health, and Reduce Environmental Impacts. You can get your own copy through the publisher at islandpress.org or click the link in the show notes to take you directly to our affiliate page. Remember to subscribe to the show wherever you listen to podcasts, and please rate, review, and share the show. Thank you for listening, and we'll talk to you next time on Booked on Planning.